In this video, we're going to go over page 2 of the ACT. This has problems 8 through 15. So since that's 8 problems, you should have a goal of being able to complete this in about 8 minutes, maybe a little bit less since this is early on in the test, so a little bit under a minute per problem, hopefully. I'd recommend that you either pause the video and try all 8, giving yourself either 8 minutes or just timing yourself and seeing how long it takes. Or I'll also give you time throughout the video to try each problem first before I explain it myself. I do also have timestamps in the description, so feel free to skip around in this video if there's a specific problem you're looking for. Alright, so number 8 says, Manish drove from Chicago to Baton Rouge. At 8 a.m., he was 510 kilometers from Baton Rouge. At 1 p.m., he was 105 kilometers from Baton Rouge. Which of the following values is closest to Manish's average speed in kilometers per hour from 8 a.m. to 1 p.m.? Go ahead and pause the video and try this for yourself first. So the problem is looking for kilometers per hour. Let's first figure out how many kilometers he drove. So his first distance was 510, and then later it was 105. If we subtract those or find the difference, that will tell me how far he drove. So 510 minus 105 is 405. So that's how many kilometers. And then it's kilometers per hour that they're looking for. So let's find out how many hours he drove. So from 8 a.m. to noon would be 4 hours, plus 1 more is 5 total hours. So if we do 405 divided by 5, we should get 81. So 81 kilometers per hour, and that is answer H. The ACT categorizes this problem under functions and modeling, since we basically had to use the formula for average, and this is of course a modeling problem. Number 9 says, in the figure shown below, E and G lie on segment AC, D and F lie on segment AB, segments DE and FG are parallel to segment BC, and the given lengths are in feet. What is the length of segment AC in feet? Go ahead and pause the video and try this problem on your own first. So before we start working on this problem, I just want to mention that really most of this you don't need to read. And I'm not trying to upset any of your geometry teachers, because they probably told you that you can't just look at a diagram and assume anything, but the ACT isn't really out to trick you like that. So we are going to kind of assume some things. We don't really need to read most of this. It's just asking, what is the length of AC? All right, so let's take a look at AC, which is this whole line segment here. And what we need to recognize is that we have a whole bunch of similar triangles. So there's the small one here, and we can tell that from the left side to the right side, we just have to multiply by 2, right? 8 times 2 is 16. And that's going to happen in all of these triangles. So I could highlight this one, like from A to F, this middle, or this like medium triangle, would be the same thing. Now we're not going to just multiply 7 by 2, because 7 is just part of this little trapezoid down here. What I actually want to do is multiply all of this by 2, and that would get me this whole line segment here. But actually, I don't even care about that triangle. I care about this big triangle from A to B, and from A to C. So from A to B, if we add 8 plus 7, that's 15, plus 6, that's 21. So this whole line segment on the left is 21. If we multiply that by 2, that will give me the whole line segment from A to C. 21 times 2 is 42, so the answer is D. And the ACT categorizes this under, of course, geometry. Number 10 says, Katerina runs 15 miles in 2.5 hours. What is the average number of minutes it takes her to run 1 mile? Go ahead and pause the video and try it on your own, and then we'll work through it together. All right, first off, they were nice enough to italicize minutes, just to make sure we notice that, because they did tell us about 2.5 hours. So first, let's change 2.5 hours to minutes. Of course, there's 60 minutes in an hour, so we'll do 60 minutes times 2.5 hours, or 2.5, and that gets us 150 minutes. And they want to know the average number of minutes it takes her to run 1 mile. So if we take the 150 minutes and divide that by the 15 miles that she ran, we would get 10. So the answer is G. And this problem falls under number and quantity and modeling categories. Number 11 says a bag contains 8 red marbles, 9 yellow marbles, and 7 green marbles. How many additional red marbles must be added to the 24 marbles already in the bag so that the probability of randomly drawing a red marble is 3/5? Pause the video, and after you've tried this on your own first, we will work through it together. First of all, as a general test-taking strategy, I'm going to demonstrate in this problem, I'd recommend that you try to draw things out as you're reading through a problem. I'm going to color code here. That's not something you can do on the test, but I'll just want to demonstrate, like as I'm reading, a bag contains 8 red marbles, 9 yellow marbles, and 7 green marbles. And I just like to draw or write things out as I read through problems sometimes, and it helps kind of focus my thinking. how many additional red marbles, so I don't know how many, I'm going to call that X, that's red marbles, must be added to the 24 total. So this 8 plus 9 plus 7 is currently 24, but we're going to add some red marbles here. Now the thing to remember is as we add red marbles, we're also increasing the total number of marbles. So the X kind of belongs over here too. So if we're looking for a probability of drawing red, we want to remember that probability is the wanted outcomes over the total outcomes. So the wanted outcomes in this problem are the red marbles, which is 8 currently, but we're going to add X to that, some number of more red marbles. And then the total number of outcomes is the 24 total marbles that we have to work with. But again, as we increase the number of red marbles, we're also increasing the total number of marbles. And we want that to be 3/5. Now, you could try to solve this as like an equation. That's fine. Might take a little bit of time to do that. We also have 5 options for answers that X could be. So you might as well just plug in each of those and see what you get. It might be faster to do it that way, especially if you're using a calculator. So if I start with letter A, 11, we'll plug in 11, 8 plus 11 over 24 plus 11. If you're using a calculator, just make sure that you plug these in parentheses so that it, if you're going to put this all together, so that it calculates it correctly. Or you can just do a little bit of mental math. I like to do kind of a mix, right? So 8 plus 11 is 19, 24 plus 11 is 35. And maybe type that in your calculator and see if you get 3/5. Or, 3/5 is 0.6. So that's kind of our target. Also, I know that 19 can't be simplified because it's a prime number, so I know that can't be the answer. So I'll try B. So I'm going to plug in 16 now. So 8 plus 16 over 24 plus 16. 8 plus 16 is 24. 24 plus 16 is 40. And you can either simplify that by dividing the top by 8 and the bottom by 8. And you do get 3/5, or again, just type it in your calculator and look for 0.6. So the answer here is B. And this one falls under statistics and modeling. Number 12 says, in the standard XY coordinate plane, the point 2, 1 is the midpoint of CD. Point C has coordinates 6, 8. What are the coordinates of point D? Try this problem on your own first, and then we'll work through together. All right, so let's sketch out what's happening in this problem. We have some line segment CD. It tells us that point C is at 6, 8. So let's see, 6 might be like this, and then 8 would be up there. So this is kind of a rough sketch, but there's C. And then there's a midpoint at 2, 1. So 2, 1, something like that. There's our midpoint. So if C is here, and this is the midpoint, D must be like down here somewhere. So starting at point C, if I work my way to the left first, we had to go from an x coordinate of 6 to an x coordinate of 2. So we had to go back 4, or minus 4. If we do that again, from 2 to whatever this is, 2 minus 4, that would be negative 2. So this is kind of not to scale anymore, but there's negative 2. That's the x coordinate. Now let's do the same thing for the y coordinate. So again, starting at C, to go from the first point to the midpoint, we had to go from 8 to 1. So that was down 7. And if we go from 1 down another 7, 1 minus 7 is negative 6. So the coordinate is negative 2, negative 6. So the answer is G. And this falls under the categories geometry and modeling. Number 13 says, at his job, the first 40 hours of each week that Thomas works is regular time, and any additional time that he works is overtime. Thomas gets paid $15 per hour during regular time. During overtime, Thomas gets paid 1.5 times as much as he gets paid during regular time. Thomas works 46 hours in 1 week and gets $117 in deductions taken out of his pay for this week. After the deductions are taken out, how much of Thomas's pay for this week remains? So Thomas worked 46 hours, and we know for the first 40 hours he works, that's regular time, he gets paid $15 per hour. So we're going to do 40 hours times $15 per hour. But then he also worked 6 more hours, and that counts as overtime. So we're going to do plus 6 more hours times. Now, it would normally be $15 per hour, but we have to multiply that by 1.5 since it's overtime. And we can actually just do that all together there. Now, this represents how much total pay he got for the week, but then they had to subtract or deduct $117. And at this point, it's really just a bunch of mental math or calculator work. And so working through that, you should get 618. And I've kind of just quickly summarized that work shown here. So the answer is D. And the ACT categorizes this under integrating essential skills and modeling. It's really just like order of operations, adding, subtracting, and multiplying that we needed to know here. Number 14 says, at Sweet Stuff Fresh Produce, the price of a bag of grapes depends on the total number of bags purchased at one time, as shown in the table below. In 2 trips to Sweet Stuff this week, Janelle purchased 3 bags of grapes on Monday and 4 bags of grapes on Wednesday. How much money would Janelle have saved if she had instead purchased 7 bags of grapes in 1 trip on Monday? So she first purchased 3 bags, and that means she spent $3 per bag. That would be $9. So her first trip cost her $9. And then later she bought 4 bags. So 4 bags would be at $2.80. So we're going to have to do 4 times $2.80. And that's $11.20. So the way she bought the grapes, it cost her $20.20. If she had just purchased 7 bags at once, we can do 7 times $2.60. And there we should get $18.20. So if we do $20.20 minus $18.20, we see that she could have saved $2. And this problem falls under the categories integrating essential skills and modeling. All right, this is the last problem on page 2. Number 15 says, what is 3% of 4.14 times 10 to the 4th power? And this can basically be typed directly into your calculator. You do need to remember that 3% is written as 0.03, or at least 0.03 if you're typing it into your calculator. So 3% of 4.14 times 10 to the 4th power. You should be able to just type all that in one line. Now 10 to the 4th power just means there's a 1 and then 4 zeros. And then if you multiply that by 4.14, it would be 41,400. And then we just need to multiply that by 0.03. And if you do type all that in, you should get 1,242, which is answer A. And this falls under the category algebra.